Good day everyone. My name is John Rases Mandupig from Java State University. Now, in this video, we will talk about the concept of Cipher. So, concept of Cipher, we will talk about the history and how Cipher really works. So, Cipher is a process of encrypting and decrypting data. Simple as that. In this picture right here is uh, a man who composed his own type of cipher, which is very simple and common to nowadays, which is Julius Caesar. Julius Caesar. Julius Caesar is a third triumvirate. Triumvirate. I don't know what this spelling, which is a triumvirate soldier in Rome, in which he used his own type of decrypting data, which is the same purpose, which is trying to communicate his soldiers, which is actually very nice in the concept of cipher, uh, which is also called the Caesar cipher. So Caesar cipher is basically uh, what what this text is really meant, and how the Caesar cipher process really works. In order for us to understand what type of code really meant with the use of Caesar cipher, which is actually pretty controversial in such a way. So to express Caesar's process mathematically, we will start encode first the alphabet, in which alphabet has 26 letters. So he come up with this formula Z26, and in fact, Caesar's encryption method can be represented by the function, and of that assigns to the non-negative integer p is greater than or equal to 25, which means 25 is greater than 1, then 2, or any until 25. With this come up with this formula. So f p equals to p plus 3 mod 26. So we'll be using this formula in encrypting and decrypting data. Wait, that's not. So 3 here is a given. So you can put 4. You can use 4, you can use 5, you can use 8. But always remember that it is mod 26, so you will not use 27, 26, 27, 28, greater than 26, because encrypting and decrypting data is very hard when you encode and when you put 27 or more. So let's put an example. So here's an example of encrypting and decrypting code using Caesar cipher. So here is our table represents different codes with different codes of letters and numbers. So A represents 0, B represents 1, so on and so forth. So encrypt the plain text. Discrete mathematics is quite enjoyable using the shift cipher and shift k equals 5. So basically, we were trying to encrypt data using this formula right here. So first replace, so we were using p a k, so p f sorry f plus p equals to k. Oh, sorry, k. So k plus 5. So first is replace the letters into coded numbers. So discrete mathematics is quite enjoyable. So this is our sentence right here. So we will uh, replace the letters into coded numbers. So first is discrete. So D. So what number represents D? So D represents number 3. So we put 3 here. Space. Then I represents 8. So it is very simple. You will put the number accordingly to the numbers represented. So C is 2. So yeah, very simple. Very simple process in creating this type of data. So I will continue here. So this is the encrypted data text. Next step is uh, next step is we will encrypt the data using this formula right here. So it's very simple. So 3 plus 5 is equals to what number? Equals to 8. So the 8 plus 5 equals to 13. So yeah, very simple. You will just add these numbers using this uh, k right here, since k is the integer. You can use any integer you want. You can use p, you can use y, which is represents the integer value. So so I will continue the solving process. So you'll be wondering here, this one, 24 and 2. So if you add 24 plus 1 equals to 29, right? So 29 minus 3 equals 29 minus 26 equals to 3. Basically, so we have 3 remaining numbers. So 27, 28, 29. So that is the reason why the encrypted data is 2. So you might confuse. So next process, the last process is, so the last process is to replace the numbers into replace the coded numbers into letters. Sorry, replace coded numbers into letters. So first is discrete. So 8 equals to I. 8 here is I. So we put I here. I 13 and X H Y J Y J. I think it's correct. Y J Y J. Okay. Next is RF. So this is the final output in encrypting this data right here. As you can see, you will not understand this code, right? Very difficult. And if you want to try to, for example, this code right here, and you want to find out what this sentence really meant, so we will try to decrypt here. Uh, we will try to decrypt this code into a formulated the plain text that we use right here. How we will transfer? How will we transfer this one into this one? We'll transfer this one into this one. So yeah, let's start. So in this process, we will try to decrypt this message into this message right here. But how? Very simple. We will use this formula. You will this formula instead of plus. Wait, I just transfer plus to minus. Instead of plus, we will try to subtract those coded text into minus 5. Before we try to encrypt, adding 5, then decrypt, we will subtract those, we will subtract minus 5. It was very simple process right here. So first is, well, first is to replace the letters into coded numbers. So I will replace here. So this is the also this is the more like this is the coded number in this statement right here, this type of code. Next is subtract. Use this formula in decrypting this data right here. So 8 minus 5 equals to what? 3. So yeah, very simple. 13 minus 5 equals to 8. 23 minus 23 minus 5 equals to 8, and so on and so forth. So I will continue here. So this is the second process here. So this is the decrypted data right here. So we're just subtracting 3. We were just subtracting 8 minus 5 equals to 3, and so on and so forth. So the last process here is very obvious. Replace the coded numbers into representative letters. I don't know what that's a word, but I'll use it anyway. So replace the coded numbers into letters accordingly. So 3 equals to D, I, S, C, R, E, T, E. So the final is quite enjoyable. So that is the final output in decrypting this data right here. This one. So that's about it in and how you encrypt and decrypt data.